The best evidence for the Big Bang is the cosmic microwave background radiation that permeates the entire sky. And this is the relic radiation left over from the Big Bang itself and was produced about 380,000 years after the Big Bang in the visible range of the spectrum. But the universe has expanded by a factor of about 1,000 since then, so we detect it at much longer wavelengths in the microwave range. And although this radiation is smooth and almost constant over the entire sky, there are very small variations that have been mapped out by a series of space probes to produce images such as this one here. And this image shows a certain amount of clumpiness, and the denser clumps would go on to produce superclusters of galaxies in the later universe. Another line of evidence for the Big Bang comes from the observed abundances of the very light elements, hydrogen, helium and lithium, and they match the theoretical models of how fusion reactions would have occurred in the very hot, dense, early universe. In the first few minutes, fusion reactions would have converted hydrogen into helium, and we observe in the universe around us that a quarter of the ordinary matter is in the form of helium. And it's very important that as the universe expanded and its density decreased, that these fusion reactions were turned off when they were after just a few minutes, because if all the hydrogen had been converted into helium, there would have been no fuel for stars. So there would have been no stars in the universe, and clearly we couldn't have been here to observe the stars in the night sky. All atoms beyond the very lightest are created in stars and dispersed around the cosmos in supernova explosions or other cosmic catastrophes such as binary neutron star collisions. A star system such as our own could not have existed in the first generation of stars. It would have taken many cycles of birth and death of stars to produce the elements necessary for life. These cycles would have created the carbon, nitrogen, oxygen and other elements that are so vital for the evolution of life as we see it on Earth. But it appears that these atoms do not form most of the bulk of the mass of the universe. Most of the mass of the universe, over 80%, is in the form of some sort of dark matter. And what form this takes is still not understood. When the universe is modelled on the very largest scales, it forms a sort of filamentary structure as shown in this image here. This is like a honeycomb with superclusters of galaxies aligned on filaments and strands that permeate the whole of the universe. The Galaxies are islands in the web of dark matter, or perhaps isolated mountain peaks above a layer of clouds. There's lots more about stars and the cosmos in my brand new book, The Cosmic Mystery Tour, which is available from all good bookshops and online from Amazon. Thank you for watching this short introduction to stars and how they fit into a broader cosmic context. This is the first of a series of videos that we will be uploading about the formation and evolution of stars. So, thanks again, and please come back soon for further adventures from the Cosmic Mystery Tour.